Hello and welcome back to my RC channel. I'm AndyRC and today I'm going to be showing you how I built my brushless tiny whoop style aircraft, and it was out of components from flexrc.com. Now flexrc do sell some kits that are very similar to what I'm going to build today. For example, this one down here, the Pico Owl V2, is probably the closest component wise, and this guy up here as well, the Pico Owl Light. However, I think this one has the smaller motors. However, Dimitri from FlexRC has sent me a bunch of components that allows me to build different configurations, and that is what is good about FlexRC in general. So you don't have to stick with what I build here, and you can also take things off. So if you want to build the Pico Owl, you can remove the ducts and that will just leave the Pico X, and you can get all of these different components, etc., which is what I have. So you can also buy bind and flies of these things as well. Of course they are more expensive because they have been pre-built up, but what I'm going to do is show you how to buy the individual components that I'm personally going to use in this build. So let's start off with the frame. So the frame is the Pico X main plate, and it's fairly cheap at $11.25. And then I'm going to be using this camera plate here. It's a universal camera mount, and you just stick your camera in there, and I also use some cable ties to keep the camera in secure. And if you want to use the Pico X configuration, so take the ducts off, you can also get this sleeve as well, which protects the flight controller and ESC board, but I didn't use that in this video. And then just scrolling down here, we have the Pico Owl V2 nylon ducts. These are the ones used in this video. And let's see if there's anything else. Yeah, so it is the battery mount that I use. This is for 2S, and if you want to run a 3S on this setup, you can. And that will probably make the quadcopter ballistic, but you can get a 3S battery mount as well. So moving on to the motors. Now I'm using these guys. They are the DYS 1104 6500 kV motors, and I have used them in the past on the Owl Mini, and they work very well. However, it looks like FlexRC are now producing their own motors, and these are 1103, but you'll notice 10,000 kV. That means that these motors are probably going to have a little bit more power with the smaller propellers that we need in a build such as this. However, they are going to be much more noisy than these motors, so bear that in mind. Onto the next tab, and we have the ESC board and flight controller. Now Dimitri sent me the FlexRC Pico Core already assembled. Now you can buy it in a DIY kit as well, and what we have here is a 4-in-1 ESC board. Underneath here they are 20 amp Blheli S ESCs, and then above here we have the Pico BLX flight controller as well. It's already assembled with things soldered already, and all you have to do is solder on your connector. So it shows a XT30 connector on here. However, you can solder your own connector on there, and I did that. I soldered a JST connector on there, and of course you need to tin up your ESCs and solder your motors to them. And what I like about this ESC board is they fit directly with the motor. So this one here, these three, is for this motor, these three for this motor, and those three for that one, those three for that one, etc. So that's really cool. This is the front of the flight controller there, and this is the back. You see the arrow there, so the USB does come out the side, so no need to change the board orientation there, really like this setup. So then we are going to need a receiver, so I'm using the Lemon RX DSMX satellite, and you can use obviously any receiver you like, providing that it will fit, but this one just fits. You will need to decase it though. So then onto the camera, and Dimitri sells the Eachine TX02. I am going to be using the TX03 because it's power switchable, and one thing to note about the TX03 is it is slightly wider than the TX02. So onto the hardware part of the shop, and you're going to need these standoffs here if you want to use the ducts. Now I believe it's the smallest set of standoffs that you use for the ducts, and then the slightly longer ones if you want to use the carbon fiber protector, but personally I prefer to use the ducts, and in this build I'm going to be using the ducts. You are also going to want to get some M3 nylon screws as well, and if you haven't bought the Pico Core and you want to build it up yourself, these are the standoffs for that. Those are actually M2, I believe. So onto the tools tab, and I am using the nail clipper cutter. This is really cool and I'm looking forward to showing this a little bit later. So originally I did have one of these to cut the props and use a Dremel in the middle there to cut them. It didn't really work as well as this, so this is pretty cool. You just need a nail clipper there and this works really nicely. Now FlexRC do actually sell batteries. I'm not going to be getting the batteries from here, I'm going to source them locally. But in this build you're going to want a 450 mAh 2S or a 450 mAh 3S, and of course these tattoo batteries are using the XT30 connector. I'm not going to be using an XT30 connector as none of my batteries have one of those. I'm going to be using a JST connector, and if we go over to this tab here you can see that they do sell JST connectors and XT30 connectors, as well as some 5V BECs if you need them. So that's pretty cool. On to the next tab, and they do actually sell transmitters here at FlexRC. Now I am actually going to be using the FrSky Taranis, however this is a DSM-X model, so I'm going to be using the Orange RX DSM-X module in the back of the Taranis there. Lastly we have the propellers, and those are the RotorX RX 2535 propellers, and of course as mentioned we are going to have to cut these up. So let's get on to the build. So starting off with the frame, I'm taking the first clockwise motor and lining it up. I'm then going to take the smallest screw in the packet that you get with these motors, and then I'm going to use a hex driver to screw all 4 of those in. Just line it up, make sure that the holes match. I use the shortest screws so that the back of the screw doesn't short the motor out when you tighten it up. So that's the first clockwise motor, and then this is a counterclockwise motor. So the side of the frame has got 2 cutouts in it for a battery strap if you wish, so that's how you know which is the side and which is the front. So then this is the back clockwise motor going in, again just using all of the screws and tightening them up. And then this is the last motor going in. I always find the last motor the easiest because you can just sit it flat. So just lining all the holes up there and then tighten up all of the rest. And I'm just going to move the wires out of the way ready for the ESC. And then this is me tinning up the ESCs on the Pico Cube, so I'm just going to speed that up. It's a little bit tedious to watch but very important. And now I'm tinning up these pads to add a buzzer. However, try not to pay too much attention to this because I removed it in the end. But this is me soldering the buzzer direct to the flight controller, but it didn't quite fit with the duct, so I removed it later. And this is me tinning up the negative and positive for a 1.25 pitch JST connector, which is going to connect up to the camera. Of course you can just solder the camera direct, but I like to reuse mine, so I'm not tinning up this wire here. I'm heating up the solder pads and then feeding through the wire, and that has soldered in nicely, and that's going to connect to the camera. Next I'm taking one of the nylon screws in the kit, and then I'm going to cut it short because it's too long, so just measuring it off there, and I'm going to do that for all 4 of those screws. and then this is the Pico Core going on there, and then I'm just putting the screws through to the other side, tightening them up, making sure the direction of the flight controller is correct, and then that's all 4 of those screws gone in there. So now I'm actually feeding the wires around the standoffs. This is something that Dimitri recommends. Of course, you can just solder the motors direct, but apparently the ducts can get in the way of the wires if you do that, so just ravel around all of the wires through the underneath of the ESC board, and then that's going to come back on itself. So I've done that for all of them, and then I'm going to cut those wires short. So just a pair of cutters there, just measuring this up. So do that for all 4 of them. They're still going to link up to the same ESC pad, which is specific to that motor. So now I'm taking my wire strippers and carefully just stripping all those wires. You can use a pair of cutters to do this as well. However, I find that this is a really efficient way of stripping wires. And the last motor, I unraveled the wire because it was just a bit easier to get to. So now I'm starting to solder in these wires, so you can see there the motor and the corner of the ESC is where they match up, so pretty easy to know which motor goes to which ESC pad. Now I didn't tin up these wires. They have a bit of enamel on the wire, and you need to burn that enamel off with the soldering iron, and I found that it was really hard to tin, but they soldered into the pads nicely. Now I didn't show me soldering the pads where the buzzer is because you can't see it anyway. So there you go, that's the pads under the buzzer, you can see, and they just solder direct. Wrap around the standoff and solder direct. Now I'm taking a sticky pad that comes with the receiver, and I've cut it to length and just sticking that on the top of the flight controller, and then plugging in the DSMX receiver, which I have decased already. Now I'm just wrapping it round to the side because I don't want it to cover up the USB port. Bit of a design flaw with the flight controller there. And then this is the battery holder going in with a nylon screw and then a nylon standoff, and that's the other side. And then we've got a standoff at the front and the back as well, so that's the back one, and this is for the ducts to sit on. And then that's the front one going in. Okay, so now I tried to fit the ducts over the top of the buzzer, and it did fit, but the screws didn't quite line up. It was just a little bit too big. So of course I desoldered that eventually. So I'm trying to line it up here. In fact, I put one of the screws in, but all of the other screws wouldn't line up, and the ducts would not get the center of the motor. So I undid one of the standoffs that were close to the beeper because I didn't want to melt anything. Then I desoldered that. Of course you want to take a wire and solder it in somewhere else, but I didn't end up doing that for this build. But that's how you put a buzzer on if you want to know. So now I am screwing in the rest of the standoffs. They now fit nicely. It's just a Phillips screwdriver there for all of those to go in. And then this is the top plate for the camera to fit in. Again, that just sits on the top standoff there. You can actually fit this direct on top of the flight controller. There's a little bit of space, but I didn't do that. So you can make it slightly lower profile if you want. Then I'm screwing in the camera plate, so it just pivots here on these hex screws. So that's just one side being screwed in, and then the other. Then I'm plugging in my camera underneath. Make sure the polarity is correct, of course, but that goes without saying. And then the camera just fits in there like that. However, I found that it did move around a little bit, so I put some cable ties on it as well, and that worked nicely. So the prop cutter, this thing is cool. It's a 3D printed sort of device, and you take a pair of clippers and a 3M screw and bolt it to the device, and then you've got some little cutouts there. Now I'm definitely not using this correctly. See, I put a Allen key through the device, and then this is how the props go together, and then I stuck the prop over the Allen key, but you can see there the props are still too long to cut, so I took a pair of cutters there and then just moved it along each one and then just cut it very carefully. You have to make sure that bolt's really tight at the back, otherwise they can move and your props will end up the wrong size. But you have some notches here on this prop cutter, and this is the back notch if you're wanting to measure it out. So again, just cutting it down. I believe it's 1.9 inches for these props, but I didn't measure that. I actually just put one on the quad, cut it, and see which one was closest, and did that for all of the other props. And you can see there that all of them are the same size. So this is the finished model. It looks pretty smart, I think you will agree. Okay, so next I'm going to create a model in the taranis, so let's do that. I'm selecting an empty slot and selecting create model. Now I usually skip the wizard there and page over and name the model, so I'm just gonna call this one the FRC for Flex RC. I guess I could call it the Pico Owl, but there's so many different configurations that I'm going to be using with this model, so I'm just going to call it that. So if I press exit, the model image I usually set as TBS Discovery because it's one I know as a quadcopter. I'm going to page up because that will send me to the bottom of this menu, and what I'm going to do is turn on the external RF so you can hear it boot up there. And if we go on the back, I'm using a DSM to DSMX Orange RX module for this. So then I'm going to exit out of there and then page over to the inputs tab first of all, because we are given throttle, aileron, elevator and rudder. But I need a mode switch for my different flight modes, and I also need an arming switch. And if you kept the buzzer, you can set up a buzzer as well. So I'm going to go into there, and this one is going to be called mode. Okay, and then if I go down to the source and press enter, then I can select the switch that I want it to be on, which is that one, and automatically recognize it there. So I'm going to press exit there and exit again, and then page over to the mixer tab because we need to set channel 5 to output as well. And you can see there it selects the source as the one that we just created in the inputs tab. That's why I like to do it in this order. And then I'm just going to call this one mode as well. Well, I just put M because I don't like to type it twice. So M for mode. Exit there and then long page back to the input screen. And now I'm going to set up a arming switch. And that's going to be on my 2-position switch. taranis sadly only has one 2-position switch. So if I exit out of there and then go down to the source, press enter, I'm going to select this 2-position switch here. You can see it automatically selects it. So then exit out of there and then page over to the mixer again, and you see it automatically selects arm. I'm just going to put A up there, and then you can see this way it puts the A and M, and I don't really need arm and mode there twice. So then I'm going to long press the page button again. Now if you want to add a beeper here on a third auxiliary you can, however I haven't installed the beeper on this one, but I do intend on doing that later. So I'm just going to make one called beep, and that will be on the auxiliary 3. So if I exit out of there, select the source. Now we don't have any more 2-position switches, so I'm going to have it on that one there, and then exit out of there and then page over and then on the channel 7 of the mix I'm just going to put B for beep, and that is the model set up. So here we are in the Betaflight configurator. You can download this from the Chrome App Store. So the Pico BLX does come with Betaflight already flashed to it. However, it's version 3, I think, and just recently version 3.1 has been released. Now, I'm not going to go and reflash it in this video because I have already got some good settings on version 3, but I will do that eventually. So I've got the quadcopter plugged into the computer via a USB to micro lead, and I have modified my lead so that it is a smaller profile and it does just fit in the USB connector with the ducts on, and then that lead is plugged into the computer. So if you wanted to flash the firmware, we go into firmware flasher, select Pico BLX there, and then the latest version, which is 3.1. Now I'm not too familiar with this flight controller. Usually it's an SP Racing F3 that I flash, so I'm not sure what the manual baud rate needs to be or the reboot sequence, but I will stick a link in the below of a Betaflight installation guide because I know a lot of people struggle getting it to flash, but I'm sure it will be pretty easy. But as I say, I have got some pretty nice settings using version 3, so I'm going to stick with it for now. So you can see at the top there it says COM15, so I'm going to connect to it. So really the first thing that we want to do with this build is bind it, and when you use a Spectrum satellite you use a command in the CLI to bind it. So for DSMX, which this receiver is, you need this command here, set spectrum _sat _bind equals 9. And for DSM2 you are going to want that to be 5. And then what you do is you press enter at this point here and then type save, and this will exit. You'll then need to unplug the quadcopter from the computer, plug it back in, and your light will flash very quickly on your receiver. Then once you have turned your transmitter on and press the bind button, it will bind, and then you can power cycle it again, come back into here and then set this command again, but set it to 0, and that will stop the binding procedure. Again, you have to press save, otherwise it won't save. So next I have gone into the expert mode here, and that is so we can see the failsafe options. But let's go into the setup again, and every time you exit out of the CLI it disconnects you. It's kind of annoying. But you can see there that I have got the quadcopter on a fairly level surface. Yeah, it's not quite right though, so make sure it's on a level surface before you calibrate the accelerometer here. Go into the ports tab. So I've got the serial RX switched on, the UART3 for the DSMX receiver. Let's go into configuration here, so it's set up as quad X, and then there is no need to have the board aligned at all because the USB connector already comes out of the side, so that's fine. Up here we got one shot 125 enabled. I've got motor stop turned off so that the propellers move when I arm the quadcopter, so that I have control at 0 throttle. And then the minimum throttle, as this is Blheli S, you can have it set really low. And then the max throttle is correct at 2000 there. So if we just come down here, now I do have the VBAT enabled, however, as I don't have a buzzer connected, that's not really going to be any use, so I won't go through that. But the VBAT is connected to the flight controller, so actually if I just plug a battery in here, you should be able to see that. Let's do that. So we're looking at the top there, so you can see that it is working. So just come down here and all this is turned off. Onto the failsafe here, and it's actually set to land. So I need to change that because it should be set to drop. So I have changed some settings, but obviously not all of them. So I'm going to save and reboot that because we want it to drop when the failsafe kicks in. So let's go on to the PID tuning. Now these are completely the stock Betaflight PIDs, and it actually flies pretty well on those. So I'm going to keep everything there stock, which is unusual for me. So onto the receiver there, and you will see that everything is working fine and all of my auxiliaries are working fine. So let's go into the modes here. So I've got my 2-position switch up here and also air mode on auxiliary 2. I've got angle, horizon and acro over here, and then I did actually set one up for a beeper. Of course there's no beeper installed. I am going to solder one up at a later date though. So if you are building this from scratch, then you are going to want to calibrate the ESCs, and so make sure you have the props off when you do that. But the way that you do that is you unplug the battery, tick this, put this up to the top, plug the battery in, and you'll get some beeps going on, and then reduce this to the bottom, and then it will have calibrated your ESCs. Ooh, one thing I think I may have missed if we go into the configuration, it's important if you're using DSMX. So for the receiver, it's set to serial based receiver, and for DSMX you want 2048. So I will just go into the CLI again and type in version, so you can see that I'm using version 3. Yes, that is version 3.1 now, and I imagine a lot of people say you don't know what you're missing by not upgrading to 3.1. I'm going to do it, just not in this video. So next we're going to want to take a look at Blheli suite, because I soldered all of the motors direct to the ESCs and we have no idea what direction they are spinning in. So you're going to want to disconnect from Betaflight before you do that, otherwise it's not going to connect. So I'm just going to disconnect to that, and then I'm still using this old version of Blheli suite, but there is a configurator now. I need to upgrade to that, definitely. So I have got the battery plugged in to the quadcopter at this point. So again, make sure the props are off. If we go into this selection here, you need to make sure that clean flight is selected as the pass-through here. So I can select COM15 now and then press connect. And then we're going to want to press check here and then OK, and this should all turn pink to show Blheli S. Now, all of the ESCs are at the bottom here, and I'm just going to deselect all of them and show you the rotation because mine were all over the place. So motor 1 is the bottom right motor, and that one should spin clockwise, and it wasn't, so I've reversed it. So you reverse it just by moving this tab here, and then right setup. So motor 2 is the one above motor 1, so the front right if you are looking at the quadcopter on the top and the front is pointing that way. That one was fine, so normal, so that one should spin counterclockwise. Then motor 3, that is the bottom left motor, and again that one was spinning counterclockwise correctly. And then motor 4, which is the top left motor, that one should spin clockwise, and it wasn't, so I reversed that. So as I say, right setup. I also turned braking on for all of them as well, and that is this here. It just means that the motors stop really quickly when you disarm it, and it's also very good if you want to use a 3D setup. So that is the Blheli suite setup. Okay, let's go for a takeoff. I'm going to arm it on my switch. And it's unbelievable how quiet this thing is for a brushless model. It's just so quiet compared to anything else that I've flown, such as the Aurora 90. Plenty of punch. Loads of punch. Very fast machine. Let's stick it into acro mode. Yes, this is fantastic. Dimitri from FlexRC, you have done it. You have made it possible to have a brushless tiny whoop with loads of power. This is what people want really from a tiny whoop. And the brush models, they just don't quite cut it. Show you that punch again. Absolutely bags of power. This is going to be fun doing FPV. I just want to keep flying it. See if I can get some close-in maneuvers done. This could be a disaster. Just so much power to pull out of any maneuver you throw at it. See if I can get it close to the camera. It's very windy today. That's the best I can do. This thing is fantastic. Let's come in for a landing and do some FPV with it.